Yeah, because that is a little bit in depth, means it will give you a more clear
Oh,
idea.
okay,
So
okay.
how you,
Yeah, I
yeah.
will do that.
Yes. So we are at this stage, right? We will be
Mm-hmm.
seeing some supervised learning algorithms,
Yes.
right? So
Mm-hmm.
if you
Mm-hmm.
remember what was our supervised learning, just let me take the pen. Yes. So basically our machine learning is divided into three parts, right? Machine
Yeah.
learning model.
Mm-hmm. Yeah.
One
Supervised,
was your
unsupervised.
supervised, unsupervised, and
Mm-hmm.
your reinforcement, like, right?
Reinforced. Yes.
In
Yeah. Mm-hmm.
supervised, we have a algorithm that is your linear regression,
Mm-hmm.
right? Regression. This is basically your algorithm, right? As we have discussed, algorithm is nothing but your mathematical expression, right?
Mm-hmm.
And yes, so this is your supervised type of your supervised machine learning. And in supervised machine learning, we have seen that there are two kinds, right? One is your regression. Regression is like you're predicting some value, like for continuous numbers, right?
Mm-hmm.
Like
Mm-hmm.
price of your house or price of flight price prediction, right? And in
Mm-hmm.
categorical classification, we have our model help us to classify, like between dog and cat,
Mm-hmm.
or will the person buy the insurance or not, like this kind
Mm-hmm.
of data we have in our
Mm-hmm.
classification problem.
Mm-hmm.
Okay, so this
Mm-hmm.
linear regression is a your regression model. It will try to basically predict the actual value, right? Continuous value.
Mm-hmm.
Okay, so to understand linear regression, let's first take an example, right? So basically, let's take an example. Suppose you are starting with a startup. Okay, so let's just imagine like your startup has grown to a certain level, and now you came to a point where you need to hire some engineers. Okay, so now you came to a point where you are not sure whether what will be the salary that will be given to your employee, like what should be the salary that you should give to your employee for that particular job, right? So
Mm-hmm.
how can this process this thing can be handled, right? So to manage this, we can create we can find some data about it, like and we'll try to see on the basis of their work experience, right? We searched on some experienced, we searched for collecting, we collected some data, like we collected the work experience in years, right?
Mm-hmm.
And we took their salary, like from somewhere from other companies or some other resources, right? Then
Mm-hmm.
what we try to do is we try to see what is the, basically here what we are doing is here we are trying to create a salary predictor, right? It will try to predict the salary. Okay, so we went and we collected some data, and you saw that we got some data like this. Okay, like if for some person like with a 5.8 years of experience, that person got a salary that was like 75,000. Okay, and a person with 77.2 years of experience got a salary of 12,000. Okay, so it would be like I would be missing here 10. Okay, like 1,20,000. Okay, and with a person with 3.1 years of experience is having 48,000 salary, right? So suppose like that we collected some data. Okay, now what we will try to see, either we will try to do it manually. Okay, but doing manually will not solve the problem, right? By seeing
Mm-hmm.
this data, you just can't say that what should be the salary of 8 years old a person, right? You can't
Yes.
just say by seeing this data, or you
Yes.
can't say
Mm-hmm.
what is the salary given should be given to a person with 2 years of data. right? You can't just like see this data and say that. But
Mm.
what if we give this data to our linear regression model? And linear
Mm.
regression model will come up with a certain set of rules, right? We can say as a
Mm.
certain set of rules that a model have to follow, right? And then on the
Mhm.
basis of them, it will try to regress, or it will try to predict
Mhm.
any number, like that may be range from 48,000 or 16,000 to
Mhm.
maximum 2 lakh, right?
Mm.
Like
Mm.
it can range from across these many numbers. Okay, these are the
Mhm.
continuous number, right?
Mhm.
So our model can able to predict the salary based upon the number of experience, right? Number of
Mm.
years.
Mm. Mhm.
Yes, so I'm recording the screen. Yes, so yeah, so what we will do, okay, so our regression model will first of all basically, let's first of all don't do anything, let's plot this data, okay, in a graph.
Mm.
Okay, so we
Mhm.
say it as a scatter plot. Okay, we
Mm.
have seen a scatter plot, right? Scatter plot. So I've sent you a bivariate analysis video. In that you may see a scatter plot section. Okay, so
Mm.
I have shown you how to draw a scatter plot there. Okay, so what we will do
Mhm.
is we will draw a scatter plot for better understanding. Okay, so now
Mm.
let's plot this data. Okay, like
Mhm.
a person with a 5.8 years of experience is getting a salary of 75,000. Okay, so
Mhm.
7.5 here will come approx here, is getting
Mhm.
75,000. Okay, something around
Mm.
here,
Mhm.
this. And the person with 7.2 is getting 1.2 lakh. Okay,
Mm.
7.2 and here 1.2 lakh.
Mhm.
This way we are creating a plot. Okay,
Mhm.
3.1 will get something around, are you getting the idea means,
Yes.
right?
Yes. Yes. Yes.
Isn't
Yeah.
it confusing, right?
No. 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 Not.
4.4 is getting 3
Seven.
3.7, right? And similarly like 2 is getting 16, right? And 6.7 is getting 1 lakh 40. Okay,
Yes.
6.7 will be here, 1 lakh 40, this. Okay, so this
Yeah.
was, the data was small, so we got
Mhm.
this kind of a plot. Okay,
Mhm.
so in linear regression we basically try
Yeah.
to fit a line. Okay, so
Mhm.
we will
Mm.
try to draw a line that will best pass through the all the points. This line can be this line can be this, or this line can be the line can be that which passes through the maximum number of points,
Mhm.
right?
Mhm.
So some people might say this line
Mm.
is the best as this passes through the 3 points, right? Some people
Mhm.
might say that this is the best fit line because it has the reason for best fit line for different people may be different, right? But
Mm.
actually what is the best fit line? So in linear regression, right, we
Mm.
try to minimize this distance,
Okay. Mm.
this distance. Let me take the another color, this distance, right? this this
Mm.
this and whichever line that gives this distance, the least distance between the points, will
Mhm.
be called as our best fit line. Okay,
Mm.
and this equation of line will be
Mhm.
represented by your this equation, y is equals to mx plus c. M was
Mhm.
your here intercept, right? Sorry,
Mhm.
m was your coefficient, right?
Mm.
As we have seen our earlier video,
Mm.
earlier lecture, right?
Yes.
We found the
Mhm.
coefficient and this intercept value.
Mhm.
C is your intercept. And once we find this value, now we can just put these value here, right? And in the line, in the equation of line, this is your equation, right? This C is your intercept, this point, the distance
Mm.
between this, right? And M is
Mhm.
your slope, like your tangent slope, how
Yes.
tilted the line is, right?
Mhm.
So this way, this is your M. So once you get the slope, how tilted the value is, and this value of intercept, now you can easily plot this line. Okay.
Mm.
And now you will and whenever you pass this input value, x value, you will get a certain any y value. Like if you pass any some value like 8, right,
Mm.
and you will feed this 8 value here in x, in place of this x, and there will be some value that will be given by our linear regression model, right, for m and c.
Yeah.
And this whole complete equation will be completed, and it will be calculated, and we will get some value y that will be around here, right, for if the line is this. If you are taking this line, it will predict this
Yes.
point, right, for 8 years of experience if we pass x is equals to 8, right. So now whole picture of whole game of your linear regression is to predict which line is the best, or the how to calculate this value of c and m,
Yeah.
right. So one question might be like your why don't we use right, once first of all tell me everything is clear till now, or you have any question, please
No,
ask me
no,
question.
I'm.
Yeah.
Yeah, sure.
Yeah, if you have any question at any point, just raise your hand. Okay, in here Google Meet, here you have raised your
yeah.
hand, I can see that. Okay.
Yes, yes,
Yes. So the very basic question right here may occur like you may have like, why don't we just draw a curve here, right, we not doing like this line, why don't we draw a curve here that passes through all the points like this, right.
Mm.
So basically this exactly fits all the data, right, but why don't we do, can you think of an answer, like if you
Yeah,
try.
I'm thinking like, yeah, that is math. See, for those,
Yeah.
I think we need one more variable to do the curve thing.
Actually
I mean,
not. So
variable in the sense,
yeah.
no? Okay.
So if I tell you that what was this x, right, the x was our training data, if you remember, right,
Yes, yeah.
training data, we have two data, one was our training set
Um,
and another was a test set, right.
yes,
So this x that we have plotted here, this is our training data
yes.
that our model is getting, right. So if we draw a curve around this, so our model will learn the training data. What we want is, we want to make prediction on this test set,
Yes, yeah.
we want to be accurate on this testing data, we don't want to test ourselves on this training data because it has already seen the data, right.
Yeah.
So we will try to make optimize our model so that it may give optimized value or the best accurate value on our testing data, right.
Yeah.
So suppose say if we plot this data and if I get any value here, actual value here, so you see the error here, right, is this much,
Yeah.
and if we would be using this line, the error will be just this, right. This was suppose our test data, this x value. You see now the error here that we are getting here is huge, and but when we use this line, this will be the best fit line that passes, that may have the highest chance of getting the value near the test data. Okay.
Okay.
So this scenario is your overfitting. If you get some time on your, you may take it as assignment, you may research about overfitting concept, overfitting and underfitting. Underfitting. Okay. So we don't want to overfit our data. This is like your concept of overfitting, you are just fitting the data on your training data set. Okay. Yes. Should I continue further?
Yeah.
Okay. Yes. So this was the reason that why we don't use the curve, right? The reason was this overfitting. Okay, so to summarize it up, linear regression is your powerful machine learning model that is used basically for predicting your continuous target variable. Okay, you would be having the clear understanding of it is the I think we have discussed the continuous and discrete variable, right?
Yes, yeah.
So it is helpful for predicting the continuous target variable on one or more input features. Okay, so suppose
Yes.
say here the input feature was 1, right? This was our input feature. Suppose say we have 2 input feature. So just this equation will be changed to your m1 plus x, m1 x1 plus m2 x2 plus c. Okay, and similarly if there will be 3 input features, so it will be m1 x1 plus m1 x2 plus m1 x3, right? M will be a
Yeah.
coefficient, then we will be having three coefficients, right? So yeah, so it basically helps you to predict your values. Okay, yes, so the main focus will be to minimize the sum of squared residual. Okay, so suppose now I think we haven't discussed how it find the best fit line, right? I have told you that it uses the distance between these points, right?
Yes,
Suppose
yes,
now let me erase this. Yes, so this is your best fit line. Okay, so suppose these were our points, cross were our actual points are on our training data set, right? And we plot some line L1, L2, L3 and your L4. Okay, and this is your L5. So which line you will say that is the best fit? Is your L5 the best fit?
No.
No, because it is very far from every data point, right?
Yeah.
So clearly L5 is not your the best fit line. So now your confusion will be in these 4 lines, because all of them
Yeah.
look like
No, actually L4 is the same line,
hmm,
but compared to distance,
yes, yes.
L3
So we will
and
try to see the distance, right? This distance,
uh-huh,
this distance.
yes, yeah.
So what we will do is this term is called your as your residual.
Okay.
Okay. So what we will try to do is we will try to sum the sum of squared. Why we are doing squared? The same reason as discussed earlier for the error,
Yes, yeah.
because this value is negative, right? And this is in
Negative, yes,
positive, so this will cancel that. So to handle this,
yes.
we are using this sum. And why don't it might become it most the time come as a interview question, that why do we do squared, why don't we use absolute value, like just ignoring this negative sign.
Okay.
Like you may do some research on this. Okay, like why don't we use the absolute value, why do we use this sum of squared residual thing?
Yeah,
Okay.
actually yesterday class you explained this one apps and sum of square, but yeah, I'll
Yeah,
find out on
yeah.
later.
Okay, so why don't we prefer this? You can use actually the absolute error, but why don't we prefer? Okay, so we prefer your ss residual, or we can say ss1. Okay, so for your line 1, your sum of squared residual or this distance will be your ss1. Okay, for your line 2 will be ss2. Okay, and whichever line have the least ss, right, sum of squared residual will be considered as your best fit. Like for this scenario I have considered ss1, sorry, ss2 I should take. Okay, this line is okay, so let me tell you why do we use absolute value. Okay, because see, if you do square, right, this is like one of the reasons, because if you do square then you will find that if you take this value, like if your value is in okay, so sorry, this was not the reason for this. Okay, so this is another reason. So basically yes, so if you square this value, right, your value will go very up, very high, like if your the
Yes.
distance is high,
Mm-hmm.
right?
Mm.
So yes. So where we started, yes. So this was your sum of squared residual, okay. So L2 was having your least
Mm-hmm.
residual, yeah. So you see, if you do square of this value, it will be not much higher, right? Of this value, it will be not much higher. Once the value get started with higher note, right, the
Mm.
value of your squared will be like will increase exponentially, right?
Yes, yeah.
So it will act as your penalty for your
Mm-hmm.
model. Like if
Mm-hmm.
you get any value higher, it will act as the penalty, like this squared thing,
Mm-hmm.
and it will try to minimize it. Like if I put any x here, right,
Mm-hmm.
so this value will become eventually very higher, okay. So it will try to tilt this line with a very higher angle or higher slope. It will try to take a value near this point, like it will try to minimize the most of the line, like, are you getting my point? The line,
Yeah.
right,
Mm-hmm.
the line don't want to actually fit over some values and take the distance for some value very high, okay.
Ah, okay, okay. That is about to ask you.
It
Okay,
want
yeah.
to just approximate for every value,
Yes, yeah. Mm.
like the it don't want to be perfect, right?
Mm-hmm.
We don't want to be
Mm-hmm.
perfect, like for
Mm-hmm.
if we predict some value exactly, then
Mm.
it is the thing of like a god, right? You are not a
Yes,
god actually,
yes,
right?
yes. That.
So
Mm.
we don't want to perfectly predict, we just
Yeah.
want to next
Correct.
to the perfection.
Yes, yeah.
If we can like do next to the perfection for every point, we don't
Mm-hmm.
want
Yeah.
like we are perfect for some value and we are completely opposite for some value. We don't want
Mm-hmm.
that. We want
Yeah.
for every point we can just predict next to perfect, not
Mm-hmm.
exact but next to perfect. So that is the
Yes.
reason why we choose the line that will be your mm, mm, approximate all these points, right? So that can be done by taking your sum of squared residual, right? So whichever the
Mm-hmm.
value of this line will be less, it will be taken as your best fit line, this value, okay. And now once we have found the best fit line, everything is solved. Now just you have to put the input value, and corresponding output value will be your
Mm-hmm.
corresponding y-axis will be your output value, okay.
Mm-hmm.
Like you have to do like if 9, so the output value will be your around 130k. Like see, you may see that this value is increasing, right? If it will be
Mm-hmm.
10, it will be something like 150k, right? It is like a intuitional, right? Like here we
Yeah.
started from 1 to, increase, this is increasing, so your salary is also
Mm-hmm.
increasing,
Okay,
okay.
here quick
Yeah,
question.
yeah.
See, here L1 between L1 and L2 is not the minimum. I mean least distance. You said like L2, right?
Uh-huh. So see, here what I saw, I explained you that we don't
Mm.
want to see these value like x this, right? This is very far from this value,
Yes,
and,
yeah. Uh-huh.
and if we do square for this value, and it will be more far, like it will put penalty on
Yeah.
it,
Mm-hmm, mm-hmm.
right? And so this prediction will be very wrong.
Yes.
This
Yeah,
prediction
that
will
one
be
I.
also very wrong.
Mm.
This will also be like most of the time. It's you may see that this is actually very deviated from this, right?
Yeah, that one, but yeah. See, what about, yeah, you pointed this one, right? L1 between L1 and L2 it's least, right?
L1 and L2, like L2 will be the least sum of squared error. What are you means? Can you repeat your question? I actually didn't get
Yeah.
it, I think.
See, yeah, yeah, yeah. See, 50K up about to 50K is the L1, right?
Yes. So your this line is L1. This.
Yes, this one is L1, the next one is L2, right? Can
Yes.
you come down? So, yeah, see this point L1, yeah, there is a release point, right?
Hmm.
Why are you taking like L2? That is my question.
See, oh, okay. So why I'm taking L2? No, why I'm not taking
Uh,
the L3, right?
Not L3. L3 it's
Sorry,
far.
L1,
I
L1,
don't want
L1,
to.
L1, L1.
L1, yeah. Mm.
So you see this L1 is like what I told you here. We don't want the perfect value. We want the next to the perfect for every value.
Okay, okay, then.
For every value, just keep
Mm-hmm.
this in like in your mind. We want
Mm-hmm.
next to the perfect for every value. Here, if you take this L2, these
Mm-hmm.
are for every value. You see the distance is like not much big. This is less,
Okay,
this is
yeah.
also not that
Now,
big, this is
now I
also
got.
not that big.
Mm-hmm.
But if you take the
Mm-hmm.
L1, some values are perfect, right? For
Mm-hmm.
some
Mm-hmm.
values actually we are doing 100%, but some
Mm-hmm.
values are very far. This is means like very far, right?
Mm.
And if we will since we are doing sum of squared error, right? So once you do the square, it will be even
Yeah.
far, even further
Yes,
far,
yes. Yeah,
right?
yeah, that point I got. Okay.
Yes.
Okay.
And for the
The
short
next
distance,
duration.
yeah, and for the
Mm-hmm.
short distance, even if you do square of that, it will be not that far.
Mm-hmm.
Like if you do the
Okay.
square of 1.5, it will be
Mm.
not much higher value.
Mm. Yes,
But
yes,
if you do
yeah.
the square of suppose 3, right? Uh,
Mm-hmm.
just if you take the, if you may try it as in your assignment, like you
Yeah,
just try to square it,
mm-hmm.
square this value
Mm-hmm.
and square
Yeah, yeah,
this value,
yeah,
and take and
yeah.
see how much times this value is and how much times this value is. Like it will
Sure,
be
sure.
3 times, it will be not
Mm-hmm.
more than 2 times, right?
Yeah, okay.
So
Mm-hmm.
this value we try to see, for every value the point should have less
Mm-hmm. Mm-hmm.
distance, less gap.
Yeah,
Okay.
that.
So your doubt got resolved means.
Yes, yes, yeah.
Okay. So this was our main focus to minimize the residual. Okay, once we find the
Mm-hmm.
best fit line, now we can just put the value for input and it will be giving you the output value. Okay.
Mm-hmm. Mm-hmm.
So, and now your doubt should be, right, how do we find the at the first place, right? At the first place, your you have to find these actually these line equation of these lines, right? Then
Mm.
only you will be comparing them, then only you will
Yeah.
be comparing them, right? So
Mm-hmm.
at the first of all, you have to find this equation of line for these lines, because
Mm-hmm.
basically these are lines are plotted, so there would be
Mm-hmm.
some equations of line, right? So like
Mm.
this y is equals to mx plus c. So how do you find this value of m and c? Basically here like your concept comes in a place that I already have explained to like in a very overview.
Mm-hmm.
You may try to do in a little depth if you have some time,
Yes.
like it is your mathematical computation, if you are familiar
Mm-hmm.
with
Yes, yes.
calculus, right? Are you
Sure.
familiar with
Mm.
calculus?
Yes, yes.
Yes. So if you are familiar with calculus, then you can
Mm.
go through this concept of your gradient descent.
Mm-hmm.
Okay. So this is the process that this is the concept that will help you to find the value of your coefficient
And see.
and intercept.
Mm-hmm.
How it basically worked, it takes some value at certain value at the any point, like suppose say plus 1 at a random. Okay.
Mm-hmm.
And it takes some learning rate, right?
Mm.
And by using this concept of calculus, it take
Mm-hmm.
differentiation and partial differentiation, and it try to come to this very point where which is your global minima, where your
Yes,
error is
yeah.
the least.
Mm-hmm.
At this point which is your global minima. Okay. And once you have find this global minima which gives you the least error, okay, so that will be your best that will be your value for your m and for your m, and same thing we will do for c for our intercept as
Okay.
well. Okay. So if you have some time after this class or any when you will be
Sure, I'll do that.
revising,
Yeah.
So you can go through this concept. How do we use gradient descent to find the value on your linear regression? Okay.
Sure.
So that is it. How your basic linear regression works. Like now, your multiple linear regression will come where you have multiple values on your input, and it will also work same. Right. The intuition behind your linear regression will be the same. Like a line will be drawn, like you will be drawn a line, it will be a multi-dimensional, right? It will be like a little bit difficult to visualize, right?
Yeah.
But the same thing will happen eventually. You will get some equation, and your machine learning model will give you some values for your variables, and you have to just give the input variable, and it will give you the output variable like this, right?
Okay. Okay.
Hope you have got this concept of your linear regression, right? To give you a code like how it works, let me take an example of your on your Google Colab. Okay, so here what we are doing is, here we are taking a data set. Same thing we are doing, importing. First of all, we are importing the libraries like NumPy as we do, matplot, sklearn. Now we have a library that is your sklearn. Okay, so the train test splitting, the same thing. Yeah, please say.
Yeah. Can you wait 1 minute?
Yeah, sure.
One
Yeah, sure.
minute.
Yeah.
Let me put you on mute. Yeah. Thank you. Yeah. Go ahead.
Yeah.
And that.
Just a second. Huh? Yes. So we were here, right? So we are using now this sklearn library, right, for your train test splitting, basically. First step. Okay, so this library for your train test split, right? For splitting your data into your training set and your testing set, right? So like 70-20, or we have discussed earlier, right? Like here we are using it like 80-20 ratio. Okay, and we are using this sklearn. In sklearn we have some already written model, right? All this process that we have discussed till now, this complete thing, like finding the best fit line, finding the value of m and c, coefficient and intercept, and performing this gradient descent calculus, right? And then finding the least the line with the least sum of squared residual, right? The whole process is done inside this linear regression model. Okay, and then we are using a matrix to evaluate our model, right? We have seen on the working of the working of your machine learning model process, that complete process, right? At the end we have to evaluate our model, so we will be using our mean squared error. Okay, so it is your squared mean, basically the on or your for your predicted value, right? It will compare with the actual value. Okay, so this contain the pre-written code that will basically compare your actual value with your predicted values, right? So now here what we are doing is, here we are generating the sample data. Okay,
Mm.
so if you I want to if I to show you the how the data looks like.
I will try. You can go over
Yes,
the
okay,
code. Yeah.
so you can play with this data, like, and you can see what is the value, of years of experience, right, and
Mm-hmm.
salary.
Mm.
Okay, so this is your data. Basically, in years of experience we have
Mm.
value that will be ranging from uh, we will be having the 10 value, right, and then
Mm.
for similarly for salaries also we will be having some value. And here if you see how we are doing the salary, here we are basically taking some values, that is your 5000, right, 5000 will
Mm-hmm.
be your, and then we are adding this with a some value like 2000 and multiplying your years of experience, so
Yeah.
that
These
we,
are some default calculation, right?
yes,
Okay.
actually we are doing this thing so that we can get a linear line, like
Oh,
so
okay.
that
Okay. Okay.
the
Mm.
salary may have some correlation with your years of experience.
Yes. Yes.
Like
Okay.
if your
Fine.
years of experience will increase, then it will be multiplied
Mm-hmm.
with this 2000 value.
Yes.
So
Yeah.
then if
Otherwise,
you
yeah.
will see a line, right, otherwise it will be cluttered, right.
Yeah. I know. Yeah.
Okay,
Now I can.
yeah.
Yeah. Mm.
So after once you have get your sample data, right, then we are
Mm-hmm.
just doing the
Mm.
splitting our data, like in training
Mm.
set and test
Mm.
set, and for your target
Mm.
variable and your, sorry, x, for x is your features, right, and y is your label.
Mm. Mm-hmm.
Basically different name for your independent variable and your dependent variable. Okay, and
Yes.
this is your
Mm.
training set and this is your test set. Okay,
Mm-hmm.
and yeah, so this train test split is used for this purpose. Okay, here we are
Mm.
passing the
Mm.
variable name, so this is your years of experience,
Yes. Yes.
this
Yes.
is your salary.
Mm-hmm.
Okay,
Mm. Mm.
and now here we are specifying the ratio in which we want to split the data. Okay,
Yes. Mm.
and now here comes the our basic machine learning model. Okay, so here we are
Mm-hmm.
specifying that we want to use this linear regression model. Okay, and
Mm-hmm.
here we are fitting our training data set and trained data set, sorry,
Mm.
training data set. In this we are fitting our
Yes.
independent variables and your dependent
Oh.
variable. Okay,
Yes. Mm.
features and your target.
Mm-hmm.
And now here we are using predict method. Okay, to give to yes, so here your basically your model is created. Okay, now
Mm.
here your value of intercept and your coefficient is stored. Okay,
Mm-hmm. Mm.
basically they have been calculated. Okay, and now if we use this predict function,
Mm-hmm.
okay, so inside this we have to pass the x value, this x value,
Mm-hmm.
this x value, right,
Mm-hmm.
this we have to pass inside this here in this bracket.
Mm-hmm.
Okay, and it will give you this y predicted value, this predicted value, basically this y. Okay,
Mm-hmm.
so we are giving this x test, that is your feature independent variable for your testing data set. We are giving that as your for your predictions. Okay, so that it may predict the target variable for that. Okay,
Mm-hmm.
that will be stored in your y underscore pred. Okay,
Mm-hmm.
yes, and now here we are just, so your so now here we are plotting our data. Okay, so that you can
Yes.
see your x test and your y test. Okay,
Yes. Mm.
and scatter plot, and you are using the color here, is specifying the color blue, and label it will be displayed to you. Okay, this is your actual data, x test
Yes.
and your y test. Okay,
Mm-hmm.
yes, wait, x test, y test, yes, so the label is your best fit line. Okay, so once you yes, so it will plot your basically your graph for your best fit line. Okay, here now on your x label it will be displaying you years of experience, on your y label it will be displaying you salary. Okay, and the title it will be displaying you this linear regression salary predictor. Okay, this is the code for your plotting this scatter plot. Okay, and now here we are calculating the sum of residuals, right? Training data minus your y predicted. Okay, that will be stored in your residual. And what is your SSR that we discussed? SSR, right, and it will be calculated using this. Okay,
Okay.
and we are for that particular line, for this particular basic best fit line, we are calculating this this SS. Okay, and we are calculating it here and we are displaying it here. Okay, you will be seeing that sum of squared residual, basically this distance, like a square of your this distance for all the variables, and it's a sum, it will be calculated. Okay, and now for slope is your and it is also storing your slope value. Slope is basically your m, this m value is your slope, and it is also known as coefficient, right? So it is storing that in this slope value, and this intercept, that is your c, or sometimes it is used as b. Okay, remember some people may also use it as b. Okay, so it is your intercept. So it is stored in your intercept, and now here we are storing it. Equation of line salary is slope, that is slope value, and this is used basically for slicing. So slicing your this value. Okay, suppose say you have the value like 3 point this. Okay, so if you use this basic your Python code, it will slice the value up to 2 decimal places.
Yes, fine. Yeah, and
Okay,
yeah.
and similarly for this it will be slicing for the up to 2 decimal places. Okay, this dot 2f. And now here we are just using the mean squared error for evaluating our model, and it will give you the MSE. Okay, mean squared error, how the value is, how accurate your model is. Okay, so here we have used this, plotted this data, right? So you may see this is your output, these points are your data, right? And since it is linear, because we have made the data accordingly, right? And now this red line is drawn to it, right? You see that we are trying to basically get close to every data point. We are not trying to cover exactly on most of the data point, right? If we want to cover the most of the data point, it should like something, it should tilt little bit here,
Yes, yeah.
right? But we also want to that we also want that these points should not be too far, right? So that's why we are taking taking the value, so that most of the points are near to each other, near to the line. Okay, so now your value, once your this plot is done, now your this value, like sum of squared residual is this much. Okay, like the sum of these distance for every value is this much, right? And your equation of your line is this, salary multiplied by experience by this. Now this, remember, this is predicted by your machine learning model, right?
Yes.
This value, this is interesting now, this value, see. And what was the actual value? Actually we used this 20,000 2000, right, at the starting. 2000 here. What our machine learning model predicted, like near to accurate, like almost like 98% or your 95%, right? It said 19,060, right? Approx 60 is your this value is multiplied by your experience, right? And also if you see here, it also predicted this try to predict this value of 5,000 that we used to generate the data, sample data, right? Here you see, here it predicted that it was 5,142. This is the predicted by your machine learning model. Okay, so these are your intercept, this value is your intercept, this intercept, or you may say this C, yes, C, and this is your slope M, the 2000 thing, which is multiplied by your experience. Now hope you got the basic, means overview of like your Good. This
Yeah.
I think this was a good example, right? Salary predictor. I
Yes.
took some time
Yeah.
to like.
Actually, now I got so basically this is how the code looks. Whatever it might be, small changes are there, but mostly the code part is like that, right? See,
Exactly.
this is lead according to what is that? One more thing. What is that? Linear. One more what?
Linear.
Um,
Mhm.
C. It starts with C, right? What is that? C one you are
Linear
saying?
classification.
Classification. Oh, so that is small changes is there, but code, most of the code part is like the same, right? That's what my understanding, right? First, yeah, this is the steps.
Yeah.
Mostly, this is, I mean,
Yeah.
yeah,
Yeah.
okay,
Since
got it.
it was like your ideal case, ideal case scenario,
Mm-hmm.
that's why we didn't
Yes.
have to do much processing. Like simply we took the data
Yes.
and we fitted here.
Yeah,
But in
yeah,
the
we didn't do any
hmm,
data processing
yeah,
something, right?
yeah,
Yeah, I mean, null data. Yeah, okay,
yeah.
got it. Mhm.
So since it was an ideal case scenario, we took the data and put it exactly like that, right? But in the
Mm-hmm.
real case scenario,
Mm-hmm.
like you have to do most of the processing, like convert these data numbers and that in that, right? Like
Yeah,
numbers into
computer,
categorical, like you have to
computer.
handle those values. Like basically just
Yes.
if you talk about machine learning engineer
Mm-hmm.
is had to handle just this much part. He have to just
Mm-hmm.
take care of this thing, like what should be the
Mm-hmm.
parameters passed here, like this random state, this test
Mm-hmm.
size, right? These are your hyperparameters,
Mm-hmm.
right?
Yeah.
Like if what
Uh-huh.
if you change this random state, so he will
Mm-hmm.
be concerning with these values. Like since it was a linear
Yeah.
regression model, it was a very simple, right? So there were not
Yeah.
much parameters to be changed, right? So but once you
Yeah.
get to
Mm.
complex and more complex algorithms, you will see there are
Mm-hmm.
some more
Mm-hmm.
number of hyperparameters. So the machine learning engineer
Okay.
is
Yeah.
concerned with these much only, like changing these value
Okay.
and might plot some
Mm-hmm.
these graphs, and that's it. Actually,
Mm-hmm.
the work is of your data. You may say data scientist to take that
Mm-hmm.
all data exploratory data analysis and those
Mm-hmm.
stuff, like converting
Mm-hmm.
the outliers, handling the outliers, and treating the
Mm-hmm.
missing values. I have all
Mm-hmm.
covered that concept in that video that I have sent to you, so you may
Mm-hmm.
see that video. Like it will be
Yeah.
helpful for you. Like
Sure. Sure.
I
I
have
will.
used some advanced techniques also in that, right?
Mm-hmm.
So you may see that.
Yeah.
Yeah.
Yeah. I will.
So after this, we can also
Mm-hmm.
I will also try to explain you a concept that is of your decision tree, right? So I think for today we will be not be covering it up,
Mm.
or should I start it? Wait, let me. So is anything missing left? So do you have any doubts till
No
now?
doubt. No. No doubt
Okay.
regarding this one. Actually, I am getting clear. This. I was wondering about code, but how does it work? What is that thing? Yeah. But yeah.
Okay. So similarly for decision tree, okay. So we can do one thing. I can explain you like working. No, it will take like at least 20 minutes. But we don't have like the code. I have prepared the thing,
Mm-hmm.
but is anything missing? Like yeah, I want to talk about the class timing, right? So once,
Mm-hmm.
can you tell me the what is the best suitable time for you? The evening, sorry, morning. Yeah, you told me that it was like
No,
around
no.
8.
Your time or my time? You say
My
you
time.
India time. I will convert my time.
Okay,
Okay.
okay, okay,
So
okay, okay.
morning India, I'm okay with any time. I don't have anything. Like for you, it's early na. 7 to 9 or 6 to 8 is also fine for your
Oh,
morning time.
6 to 9,
Or
right?
7 to 9
Yes.
for you 6 to 9, whatever convenient. I'm okay. I will make it. It's up to you. At what time you want me to do it in the
Actually, this.
India time morning.
By the way, if this 10 p.m. time is not mm, is good for you? Like it fits for me. Like 9:30 was a bit earlier because it actually colliding with my dinner time. So can we do
Yeah,
it
10
like
is
10
10.
for?
Yeah, yeah.
Yeah. So yes.
10
So we.
p.m. IST, right?
Yes.
Yeah, we can just, yeah.
So yes. So this will be working fine.
Mm.
So I have also recorded this session. So I will be sharing this with you, right?
Yes.
This here on
Mm-hmm.
OBS.